Hi, welcome to the Aruba OS 8.3 how-to video series. This is going to be a step-by-step guide to deploying Aruba OS 8.3 using the Mobility Master, mobility controllers, and how to set up both VMware and how to set up different WLANs and configuration aspects of an Aruba OS deployment. Now this is going to consist of 15 different small 10 to 15 minute long videos that can be digested as needed. So some of these things that you may not need, you can go ahead and skip, but we have a small video that covers basically every little aspect that we would have to configure. Now, our sample architecture is going to look like this, where we're modeling essentially a primary data center with a backup data center. And within DC1, or the primary data center, we have two mobility masters in VRRP. We have two mobility controllers in VRRP, and we have a switch that connects to DC2, and in DC2 we have a backup mobility master in DC2, and we have a couple backup controllers in DC2. So this is a very classic example of a simple enterprise architecture. Now, the first video in the series is basically a tour of VMware and what elements exist where. Now, you can see I've got all of my virtual machines basically waiting and ready to go. But what we did want to do is kind of go through some of the different elements within VMware that are relevant to this deployment. And the first thing that we really want to focus on is the networking piece. Now, within VMware, you can create what are called virtual switches. And so when we look at the physical adapters, these are the 8 physical adapters that exist on my ESX server. You can also see I have a number of different virtual switches that have been created, and each one of these virtual switches contains a number of port groups. Now, vSwitch 0 is the virtual switch that's created by default when the ESX server is deployed, and then these other virtual switches basically tie to different physical interfaces. Now, you cannot have multiple virtual switches connected to the same physical uplinks. So you can see over here on the left, I have uplinks of 1 inside each virtual switch. Now, if I were stacking or if I were doing LACP between my ESX server and the switch that connects the ESX server to the network, I might see 2 or more uplinks here, and there would be a separate area where those are configured. But for the purposes of this example, we're going to primarily focus on vSwitch 2. Now, vSwitch 2 is where I put all of my virtual machines. You can see that it consists of this VMNIC2 adapter that is connected to my network. And then I have a bunch of different port groups. These are essentially, think of these as VLANs that are defined within the virtual switch that are created that contain different virtual machines. Now, looking specifically at our example, I'm going to put all of my primary mobility master and virtual controllers inside this VLAN 200. I'm also going to emulate my DC2 as this VLAN 150. And so you can see I have my 2 primary mobility masters in VLAN 200 with my backup over here in VLAN 150, and then I have 2 mobility controllers inside each one. Now, another thing to note that is important within VMware, and this is what usually gets a lot of people, is that to properly emulate a virtualized switch, which is what all of our mobility masters and mobility controllers are, we must enable promiscuous mode. Additionally, if we're going to do any VRRP, we also need to allow forged transmits. So promiscuous mode allows a network adapter to hear any and all frames coming into it. Forged transmits allows us to forge packets based on a virtual or a physical MAC address, but it allows the devices to forge those frames, and that's required for VRRP to work. Now, most people will operate under kind of the older assumption that promiscuous mode in general is bad for any virtual machine or any virtual machine settings. So what you can do if you are not able or are unwilling to enable promiscuous mode and forged transmits on your vSwitch itself, you can actually create those and apply those to the port groups themselves. So to see where this is set up, we're going to go back to networking, and I'm actually going to look at the port groups themselves. So here you can see my traffic 200 port group. I'm going to go ahead and click on this, and you can see that I've allowed promiscuous mode and forged transmits inside this port group. However, if we were to look at vSwitch 2, which is where I have everything, you can see that promiscuous mode is actually disabled. This allows machines within the port group to actually enable promiscuous mode and see what they need to see on the wire, without having to actually enable it on the vSwitch itself. Now, if you truly want to isolate virtual machines within the vSwitch, you would basically create a specific port group for every virtual machine individually and enable promiscuous mode within that port group to exist, but they would not exist between port groups. So that's the first thing to pretty much be aware of within VMware regarding setting up your network. Now, the other bit that is relevant to be aware of is the Datastore, and this is essentially where the operating system for the virtual machines are stored. Now, in this particular case, I just basically have two different local disks. They're both about 1 terabyte in size, and I kind of spread my virtual machines out between these two data stores. You could also have a data store that exists on a network storage device, could be a SAN or a NAS, and that would be added here as well. So when you deploy your virtual machines, you would want to be able to elect where those data stores are going to be put. Now, when you deploy a virtual machine, and we're going to go ahead and create one very quickly, you'll go ahead and deploy as an OVF or an OVA. I'm going to hit next. And we'll just give this a name. We'll just call this demo MM. And then what I'm going to do is I'm going to essentially deploy this MM inside my machine. Now, this is where I get to pick which data store I'm actually going to put this in. I'm actually going to put it in Datastore 2. And then I choose which VLAN which port group I actually want to deploy this device in. This disk provisioning element can be used so that if you don't want to provision the entire required disk space for that virtual machine immediately, you can then provision it and it will deploy a small bit of information and then grow that disk as needed on demand. For this case, I'm going to go ahead and do a thick deployment, and I'm not going to power it on right away because I want to see what happens as I set this up. I'm going to hit next, and this is kind of my last little bit of information. I think that everything looks good. I'm going to go ahead and hit finish. And so now this new demo MM is going to be created. Now when I click on this demo MM, I haven't powered it on yet. I haven't done anything with it, but I can see some bits of information. I can see that it has 3 virtual CPUs. I can see that it's got 6 gig of memory. And I can see that it's got 4 and 6 gig of disk. There's actually 2 hard disks that are provisioned on each virtual machine or virtual MM, and that is to facilitate the ability to upgrade the controller as needed. So that if I want to grow this from a 50 device mobility master to something larger, there's a process that is outlined in the installation guide that shows you how to basically run through a process to add a 3rd larger disk. Once you power on the device, it sees this larger disk and does a migration to the new disk, and then you can delete the old disk when it's done. And once you power that device back on, it has now grown to a larger capacity device. Now, the other bit of information is to look and see how the network adapters are assigned. And so within the mobility master itself, I want to go ahead and show you what the network adapters look like. Now, this network adapter 1 basically defines the management interface of the mobility master. This is an out-of-band management interface. So when you look at show interfaces, you'll see an interface called MGMT. So if I had an out-of-band, let's say I had an out-of-band network that I called nullnet, I would assign that virtual switch or that port group to this network adapter, and when this device came up, that interface MGMT would talk over this network. This network adapter 2 represents gig 0/0/0 on the mobility master, and this is the primary interface used by the MM to talk to the network. If I needed to enable, let's say, a second adapter, which would be gig 001, I could assign this to a different VLAN. Let's say I could call this VLAN 150, and then I could allow this interface to connect. But as it is, I don't actually need it. I'm actually going to put everything in nullnet that I'm not going to use, and then you uncheck these buttons here to tell them not to connect. And so that when the MM comes up, the management interface will be disconnected, the gig 001 interface will be disconnected, and the network adapter gig 000 will be the primary interface used by the MM. Now, if we were to look at a virtual mobility controller in comparison, the only real difference between a mobility master and a virtual mobility controller is that the virtual mobility controller has one additional interface that can be used if needed. So this is still the MGMT interface, which I will assign to nullnet, and I will leave it disconnected. This network adapter 2 is gig 000 that I'm going to leave in VLAN 200. This is gig 001 and gig 002 that I will both leave disconnected. So when I do a show interfaces on a virtual mobility controller, I will see 4 physical interfaces on that virtual machine that I can use. You cannot add any more network adapters, and you shouldn't delete these. Any modification of these network adapters will result in a corruption of the defined MAC address of that virtual machine and will probably cause some operational issues that will not be recoverable. So it's highly recommended not to modify any of these adapters unless you're willing to rebuild the machine. Some other bits of information that are worth looking at when you do a deployment on ESX or on VMware. When you look at a virtual machine that you power on, which we're gonna go ahead and do this now, I'm gonna go ahead and power up this demo 8.3 Mobility Master 1. Now once it powers up, I can actually open this console into its own window. And so this is essentially analogous to being serialed into this Mobility Master so that I can watch it boot up. But this is where on the Mobility Master I'm going to do the initial deployment. So if you have access to the virtual console of the Mobility Master, you can go ahead and do the startup script from here. However, if you need to, we also support a console redirect on VMware to a telnet port. If you look through the installation guide, you can see how this is done. But essentially, we tell VMware to redirect the console access to a specific port, a specific telnet port, and then you telnet to the Mobility Master on that port, and you get the console for that device. That's pretty much it on the VMware side. There's not a whole lot to it. Once you've got the network elements kind of nailed down as far as what you want where, deploying your virtual mobility masters and your virtual mobility controllers is pretty much related to where you put those interfaces in those port groups. Hopefully this helps, but if you have any questions, certainly reach out to community.arubanetworks.com or reach out to your local Aruba sales rep or partner. Thank you.